Example 6, application of conic sections. On the sideline of each of its televised football games, the FBTV network uses a parabolic reflector with a microphone at the reflector's focus to capture the conversations among players on the field. If the parabolic reflector is 3 feet across, 1 foot deep, where should the microphone be placed? So here's kind of an image of what's going on. So we have a parabola, and I'll draw it horizontal. And it's supposed to pick up sound. We have a microphone that we want to figure out where should the microphone be placed. How far away should that microphone be placed? Well, that needs to be located at the focus. Now, to solve this, all we're told is that this reflector is 3 feet across. So this distance from here to here is 3 feet. And we're also told that the width of this is 1 foot. So from here to here would be 1 foot. That's all we're told. Now we need to solve it. So the first thing I would do is I would determine that this is a horizontal parabola, and I'm going to go look at the equation. Here are the two parabolas, and remember the way to determine is that the focus, this 4p, or the p rather, that would be the focus, needs to be next to the letter. So this would be vertical. This is the equation I need. This one's the horizontal. So I'll come back over here, and I'm going to say my equation that I'm going to be using is y minus k squared equals 4p times x minus h. Now this problem did not give us any type of shift or anything like that. So I'm just going to assume this center to be at the origin. It'll make it a lot easier. So I'm going to put this here, and we're going to have this origin going across that way. Now I have this. So my center is at, if my origin rather, is at 0, 0, that means I plug in 0 here and 0 here. Well, when you plug in 0, this will simplify to be y squared equals 4p times x. To solve this problem, I just need to plug in one more point to solve for p, because to solve for that p, I can't have any other unknowns. Well, I look and I can say, oh, I know what this point is. This point is right 1 foot, so it's right 1, and it's up half this distance, which means it's up 1.5. Just the same, if I need another point, which I don't, you can say this point is right 1, but down 1.5. I'm just going to plug this point in. So I come over here, and I'm going to say that y squared, that's the y value, is 1.5. I'll square it. And so which means it doesn't matter which point you choose. When you square it, it'll become positive. Well, there you choose a negative, because a negative times a negative is positive, or if you chose the positive. And you set that equal to 4p times x, and x on both of these is 1. I go to simplify. 1.5 times 1.5 is 2.25. It's kind of like 15 times 15 is 225. You'd have the 1.5 and 1.5 has 2 decimal places, so it'd be 2.25. That'll equal 4p. Your next step is to get p by itself, because p is the focus. I divide by 4. I get that p equals 0.5625, I believe. 5, the remainder 2, yep, 625. That would be the value here, and this would be our answer. Now this also would need to be in feet. I need to put the units with it, so I'll come back and put feet here. That's how far away from the origin, or the center, this would need to be. Now let's check all of our work in the calculator. We're saying that it is 4px, and we're saying that this is our p. So if I go over and I plug this in for p, or 4 times it would be, 4p is equal to 2.25. So this is a check. Real quick in the calculator. If I go check, we're saying that 4p for this equation here is 2.25. So it's y squared equals 2.25x. Now remember, the calculator wants x to be by itself, so we'll just divide by 2.25. So I'm going to have x equals, so I'm switching the equation around, y squared divided by 2.25. That's what I'm typing in the calculator. So to check it, I'm going to clear this. I'm going to go back to graph, first menu, graph entry, equation. It's a parabola. And I'm going to give it to it. It doesn't matter which of these forms I choose. I'm just going to choose this vertex form. Now remember, when you multiply or divide by 2.25, it's the same thing as dividing by its reciprocal. Or excuse me, multiplying by the reciprocal. So I'm actually going to put 1 over 2.25 here. We know y was by itself, so let's put a 0 here. and there were no shifts up or down either. So put a 0 there. There's my graph. And what we need is we need to make sure that focus is 0.5625 away. So go to Analyze Graph, Analyze Conic, Foci. I click the graph. I got the same value. And the other thing I could do is I could go to Table, Control T. And I need to make sure, whoops, Control T, which doesn't look like the table will actually work for this. Try it one more time. No. Well, I could try to trace it. Oh, that's not what I want to do here. If I traced it, go to Menu. Well, will it let me trace it? No, I guess I can't even trace it. You could look. We wanted that point to be right 1, up 1.5, and it sure looks like it is. So this is a correct graph. Now I have one for you to try.